Hello everyone, let's go to the next lecture. This is on classes. Classes we discussed earlier also, but this time what we are discussing is class as an object factory and other factors along with it. So let's have an example with we already have seen this. So let's have this example again. Furniture class where we have home, office. It can be further classified, but for now, let's concentrate on two things: home and office. We have bed, sofa, table, cabinet for office, for home. Then we have dining table, coffee table, which we are having in home. We won't have that in office, but definitely we can have tables and cabinets there, like we have at home also. Then we have chair and the sofa can be there in the home also and office also, but there is a difference between the two. The properties are different, and function all the functionality will be same. Everyone is going to sit on it, but the properties, that is how it looks and how comfortable it is and the space, everything could be different, maybe similar but not the same, right? So still we have some classification in the sofas also, and the chairs also. Chairs are at home also, but in office it will be office chair or maybe some training chairs or something else, right? So let's go further. So we can say that a class is a group of objects that we have already seen. It's a collection or a group of objects, and we can safely say that it is a blueprint. Like we have some definitions, but we'll come to the definition later. So a class, you can say, is it is a blueprint or a prototype. So blueprint is what? A prototype, a sample that defines the variables and the methods common to all objects of a certain kind. Certain kind we have seen, like we have the furniture class, we have the sofa, chair, and all. So they are the objects of that. Then each class actually describes possibly an infinite set of identical objects. There can be infinite number of objects. Like if you look at nature, there will be infinite objects in it. Now, so it can be called a factory also. That is why we can call it as an object factory, because in factory there can be multiple or infinite set of identical objects. So we can call it as an object factory also, right? By definition, we can say that a class is a blueprint for creating objects, provides initial values to methods, and implement methods. We'll be looking at it in detail or understand it deeply. Let me first go to the class as a user-defined type also. Then we'll come to the objects, and then we'll understand class and the objects and why it is important. Okay, so user defined type, we normally in Python we don't have user types, but in Java, definitely in C++, other languages we have data types, but here we don't have in Python many data types as such. But yes, class, we can say that it is a user defined data type. So we have different data types, and I expect students to know about what data types are and what is the difference between user defined data types, user defined data types, and system defined data types. Okay, so let's come to this user defined. So we say that a class, when we are talking about a program, it can be used to produce as many desired objects as required. So you can create n number of objects from a class, as many as you require, but with different data types. So it is therefore we can term it as a user defined data type also. Okay, so as I said earlier also, and the object word keyword has already come into picture now. So let's talk about objects also, understand that, and how important objects are. We'll see that also. So with class, we see that comes the object. That is what object was. Like furniture was in furniture, bed was an object, right? So class was furniture, bed was an object, chair was an object. Similarly, we have objects in programming also. We'll talk about that and see how they work. But first of all, we have to understand what objects are. Okay, so it is referred as an instance of a class. And to understand it, let us look at an example of Tiger. So an object, we can say it's a software bundle of variables and related methods. When we talk about the Tiger, so it is an instance of a class. That is, class is your cat family. We have talked about that. And in cat family, we have tiger, leopard, jaguar. That example we have seen in the previous lecture also. So that is an instance. Tiger is an instance of a class, an object of a class. So we can say that an object is a software bundle of variables and related methods when it comes to programming. Okay, and we'll see how it works and why we call it a software bundle of variables and related objects. Obviously, we cannot have tigers and tables and chair in our programming language. So we have the variables and the data. That is what makes a program. So an object is made up of tangible material. That is, a chair is made up of fiber, wood, iron, can be anything. And an object has properties like color, size, and the usage it has, and so on. And an object can do things and can have things done to it also. So for that, let's take another example. We'll come to that. That is example of a brain. We'll see that, and the accounts also, bank account also, we'll see that. But first, an object, it has a unique identity and behavior and state of characteristics. That is what we have to keep in mind. So what we have to keep in mind, that an object has a unique identity, behavior, and state of characteristics. So let us understand with an example that I was talking about. We have a bank account and can be an object. One may ask how. Now, how it can be an object? Now, account cannot be touched, but one can operate it, right? We said tangible and non-tangible, tangible or touchable, but account cannot be touched, but it can be operated. That is, the money can shrink, grow. You can add the money, you can withdraw the money. So balance in the account shrinks and grows. So it has properties like interest, debit, credit, and balance. So account takes in money, gives out money. So we can say that it can do things and can have things done to it. That is what we talked about objects. Okay, now let's take another example of brain. Now brain can be an object. One cannot touch it, or you cannot touch it unless you open your head, and then you can definitely touch, but then you will be no more to talk about it. So it has properties like a definite structure. We know that it has a definite structure, color, size, and it takes an input. So whatever is going on, whatever I am speaking, whatever you're listening, whatever going around us is stored by the brain. So it takes an input and processes that and gives the output whenever we require it. So it stores the input and gives us the output whenever we require it. Okay, so we will further take example of furniture also. Okay, to further understand the concept, let us consider a library. This is my favorite example actually, but let us talk about this in detail, and you will be able to understand what object is, what class is, why class is important, why objects are important, and how we use the objects. So in a library, what we have? Books, right? And books are kept in shelves of the subjects. Like if you have computer science, so you'll find computer books in a particular shelf or a particular area, you can say that. And if you talk about some literature books, you'll find it somewhere else. If you're talking about networking in computers, again, it will be classified, kept separately so that you can easily find networking books. Then we can have some history books, geography books. They all are classified and kept in their particular shelves. Now, why they are kept in their particular shelves? Because it is easier to find them that way. Right? Suppose I have a complete reference book of Java, and I keep that in English literature or a Hindi section. Now what happens? I want complete reference, and though my inventory will show in the library that the book is there because it is not issued, but you cannot actually easily find it. You have to go from shelf to shelf, shelf to shelf, and you can finally find it, right? So one thing is very clear, that classification is done to identify the things easily, right? So our human eye looks at an object and identifies that in a split second, but how the computer is going to recognize that, that is interesting to see. Now coming back to the library example, now to get the books from the library, what we need? We need a membership, we need a library card. So once we have a library card, suppose I go to the counter, I show my library card, and the book is issued to me. Now, without a library card, I cannot actually get a book from there. I may be able to access the library, but I may not be able to issue or get the book from there. So this key is a key to access the entities of a library, right? So in object oriented, instance of a class, or in other words object of a class, is required to access class members. Similarly we have in library, similarly we have in codes also. So if from a library I want to access a book, I need a library card. To access any entity of a class in a program, I need an object. So object is very important as far as object oriented programming is concerned, to access members of your entities or members of your class. So in programming language like Java, Python, C++, C++ is an object oriented programming, Java is an object oriented programming language, Python is also the same. So to access entity, here entities would be your variables, right? So a program, as I said earlier also, is a collection of data and codes, right? So any entity you want to access, you need an object. So we can say that object is an instance of a class. And in computer terms, like something like definition, we can say an object is a software bundle of variables and related methods. Now methods actually in object oriented are your functions we use in C or other languages, but here we call them methods because to access them we need an object. Okay, so let us have a look at an example code in Java, and the favorite of everyone is your hello world. So we have a class, as we have discussed I think earlier also, that Java is a pure object oriented language and it won't start without a name, without class name. So we have to give a class name to it, although languages like C++ and Python can start without a class name. Okay, but anyway, so it starts with class. Let's say it is class hello, you can name anything. Then public static void main string args, then we just simply print welcome to object oriented programming. The class name is hello and what we are printing here is welcome. Okay, so we'll be discussing about public static void main and other things once we talk about the programming, but for now we will just skip it, right? So let us have an example with Python. In Python I can simply print welcome to OOP without giving any class name, but in Java, as you can see, we have to give a class name. But in Python, if I want to give a class name, I can do that also like this. What I say is class hello, define init self name. That is we have a function initialization function self and name, where self dot name is equal to name. Then we have another function greet, that is from where the program my program will start. Print welcome self dot name to print what I am passing to it. Then we have calling the function, that is the instance. You can see that we're calling that here. You can see this one, we're calling this here. Okay, so create an instance hello and we get that, and then we call that hello greet. Okay, we initialize that, we create an instance, that is what we are creating an object to it. In Java, creating an object is little different. We'll talk about that later, but for now you can see that you create an instance and then you just simply call the function, the method we call in object-oriented programming. We call the method and hello or welcome to OOP will be displayed. It is very simple. So, but difference is there. You can see that in Java we have class and then we simply print that. Otherwise, we can simply print without a class name in Python. But if we want object-oriented programming like structure in Python, we have to start with a class. Okay. So in the next video, we'll be talking about the pillars of OOPS, and we'll be looking at more programming terms and examples, and we'll be explaining that in the programming section very soon with the examples, working examples. I'll be showing you how they work also. Okay, so how we compile and how we run. The focus will be on Python, but I'll be touching Java also, as it gives me more flexibility in object oriented programming to understand the concepts. Okay, have a nice day. Enjoy the videos.